I'm Carmel Pratt, and you're watching Massive Passive. Today we're going to be exploring 425 Grand Concourse. From top to bottom, this is a mixed-use development, huge scale, 26 stories, has a grocery store, school, community space, a ambulatory healthcare facility, as well as 277 apartment units for families in the Bronx community. We're going to be speaking with the owner and developer, Trinity Financial, the designers, Datner Architects. We'll also get a unique look into the ongoing monitoring and operations of the building. Let's check it out.
Prior to us building this project, there used to be this beautiful collegiate Gothic public school 31, termed the Castle on the Hill in the Bronx. The city owned this site. The Castle on the Bronx fell into disrepair, specifically after Superstorm Sandy, and the city was forced to demolish it because of structural issues. And then the city put out an RFP for this site, a request for proposals to build affordable housing, was for mixed use, mixed income building. And it was also supposed to be a signature type building because it's at the lower end of the Grand Concourse, a grand boulevard in the Bronx.
So there's 277 apartments. They range from studios to 3 bedrooms. So there's a real need in the community and desire from both the developer and the city's perspective to have family units, having larger units. So that's why we have this blend from studios to 3 bedrooms. And it's a meaningful number of 2s and 3 bedrooms to accommodate the families. We really want to be able to have people that live in the neighborhood, stay in the neighborhood, and continue to be here and contribute to the community.
The request for proposals asks for creating housing for 60% to 100% area median incomes. And actually, after award, we were able to increase that range much further, from formerly homeless to 30% and all the way to 130%, because it's also important to have spaces to live for professionals who want to stay in the Bronx but can't find a spot to live. And so this building does it all, and everybody is distributed on every floor. It's really the city condensed in a spot. So that was the basic concept here.
When the RFP was released for this site, it was this really kind of critical moment in time for the city where Department of Housing Preservation and Development wanted to really redefine how sustainability could be integrated into affordable housing. So for here, like really looking at what can we do? How can we push that envelope, pun intended, and introduce doing passive house at this scale, which at the time seemed really exotic and unlikely and really difficult to achieve. And I just think that acknowledging that we were able to do it, and now there are so many large, affordable passive house projects in New York City is kind of really excited.
100%. This is a project that we all in the industry look to and point to and get information from and get inspiration from. So talk a little bit about what's around here, because what's around here is also what interfaces with this building at the people level and at the program level.
So to the north is Hostos Community College, which is really kind of like a true community college. And this center is really intended for people who need additional support, whether it's like you're in childcare and you can't go to school during typical hours, or you have a developmental disability that requires additional support. And I think that is kind of really emblematic of all of the things that we're trying to do here. On the corner here, our anchor tenant will be a grocery store. All of this is within the passive house air barrier envelope, which is really exciting. Not only did it make our life a little easier because we didn't have to carve out all of these spaces, but it also means that down the line, as passive house becomes more commonplace, if someone comes in and wants to fit out their space to be passive, built to passive house standards, they can, because the air barrier is there. And we never have to worry about the air barrier between the residential and retail portions being compromised in any way, which I think is really part of the resilient nature of the building.
Now, I'm really excited to see that air barrier and that envelope in action. So let's move inside and hear and feel the difference of what the building feels like on the inside. Now inside, we can immediately feel and hear the difference of the envelope. We can also see, the depth of the facade. Talk about this space coming into the building. and how it's used.
One of the things that we really like talking about, and a lot of feedback we hear actually for this building, is that this building looks like it could be on Park Avenue. And I think this lobby is really a good indication of that, right? I mean, this idea that even though it's affordable housing, and Christoph mentioned that there is deep, deep affordability here, we really wanted to make sure that the amenity package was on par with like luxury buildings that are coming up in a lot of these up and coming areas. And so I think that this is kind of a really fantastic like way to handle that, right? I mean, for the units that are at 130% AMI and slightly more market rate, why would you come here? And I think the amenity package is really a big part of it. And immediately coming in and feeling like it's this elevated space to live, I think is a big part of it.
So we're standing up on the 25th floor roof terrace. And I mean, first of all, in terms of gateways to the Bronx, you have a spanning view of multiple boroughs, but you also see all the transitory connections that cross through this critical point. The project is very well served by public transportation. We're right by the 245 at 149th Street and Grand Concourse. It's this major hub. So we're on the flight path for planes from LaGuardia Airport, and there's the Metro North, which you can kind of hear right now. And so there's a lot of particulate in the area. And I think that that's really another reason why doing Passive House on the site was a no-brainer, right? Like, what are we really doing? We're talking about affordable housing. We're talking about healthy homes. And how can we really do that in a site that is this constrained by things that are impacting air pollution while not seriously considering building systems, the building envelope, and filter ventilation? And the other thing I think is really important here is like the urban heat island effect. I mean, there's not a lot of tall buildings nearby, but there are a lot of roofs. And we know that when there are a lot of roofs and not a lot of green space, that area is always warmer. And so to be able to provide a building that has heating and cooling so that tenants are comfortable, I think, as we see more of these extreme heat events, it's really clear how critical it is to provide cooling. Policies now push for cooling in affordable housing, but think about when this building was designed. At that time, that wasn't really very commonplace. It was like this extra thing that we were doing, like who's going to pay for it? How are we going to afford this? And I think that really having a client that's very forward-looking, Christoph is an architect by training, he's very familiar with Passive House, really helped push that envelope forward. But also having a contractor that understood what Passive House is and really came to the table with solutions and came to the table saying, like, we've had this issue before, here's a good way to address it now, all work together to make this project successful. And then for us as architects, we were able to take the lessons learned from this project and apply them to other buildings so that each time we do this, there's less of a learning curve, to the point where we were able to successfully do Passive House projects with a contractor that had never done Passive House before, because we had the experience to be like, look, we know this is going to be an issue. I know you think this is too much. Let's talk to you in terms that speak to your values, that make you feel heard, and that just really sort of emphasizing that we're working together for a common goal. We were with Monadnock Construction on this project. They had just come off of doing Cornell Tech. They had a lot of lessons that they could apply to this, like the scale was similar. And, the project is metal panel. It's the rain screen system. There's a lot of things about it that make it unique to typical affordable housing that are not really directly related to Passive House. And so being able to, like, obviously, as you said, there's no hidden facade. Each facade is very visible and each facade has a lot of glazing, but we were able to make it work through, like, solar shades. We're standing under this really beautiful solar trellis to kind of like help mitigate some of that heat gain. And then, like, we're learning all of our Passive House projects are becoming cooling dominated. And so this idea that we're so used to New York City being this heating dominated climate, and now that's not even part of the concern, was kind of a big shift in the way we think about buildings and the way we design them. So really paying attention to the solar heat gain coefficient on our glazing, and there's a lot of glazing on this building when compared to typical affordable housing projects. And we were able to integrate solar shades in a meaningful way, not only for the tenants, but also for the aesthetics of the project. So now we're standing inside a unit in the living room, and we're standing in front of one of the examples that you pointed to on how you dealt with the low loads in the building and not having terminal units that were small enough, quite frankly.
So one of the things that we did, and it's actually within this wall, there's a unit in here and it circulates and it cools and heats in that unit in the wall. We have individual tenant controls. So every resident, actually every room, every habitable room has one of these thermostats to control that piece of equipment. So it's a great way to give tenants the ability to really control their environment. They pay for their utilities, so they get to control that, and I think it's best to have it that way. Around the corner, there's a piece of equipment that's behind here, and you can see the companion supply and return. So this is where the magic happens. And the reason why that was a right sizing strategy is because the piece of equipment is really sized to provide heating and cooling for one room, but we used it to do both rooms. So we basically, because the loads are about half, we were able to be very efficient with the equipment and the way the ductwork was configured, and really size the piece of equipment to supply and heat and cool two individual rooms.
Yeah, and so in this 2-bedroom apartment, you have 2 units. One, which is this main one that's heating and cooling the open space, the living, kitchen, and a bedroom. And then in the other bedroom,
we have a wall console that provides that individual room's heating and cooling.
And here you can also see the ERV grills. So that's a supply, and in the bathroom and in the kitchen, you're exhausting.
Exactly right. And that achieves that balanced ventilation that we talked about earlier that is so important to the passive house design.
In this size building, you obviously have huge equipment, and you managed to beautifully hide it in ways that still reclaimed usable amenity space.
This space, which is actually quite large, is meant to be a recreation space for the 277 families that live here. So part of this large roof that we have here is dedicated to this really important function. It's a real important amenity for livability. I think what we saw during the pandemic was that people really wanted to have that sort of outdoor space accessible in their homes. So that was part of one of the reasons why we have this space. But on the other side of that wall is where we have all that big equipment. So we concealed it. There's acoustical properties to those barriers, but it was a way to achieve both of those kind of programmatic requirements for the building in the same fairly large roof that's on the 3rd floor of the building.
So with such a tall building, can you describe how you manage zoning and the distribution of the mechanical?
In the 26 stories that we have here, we actually created a high house and a low house. So some of the equipment that you see here flanking us is for the low house and the CUNY Hostos Center. So it was a strategy to minimize the ductwork. Instead of trying to supply all 275 apartments, we basically split that in half. And we provide the base of the building, the low house, with these ERVs, these centralized ERVs, the energy recovery ventilation system. And then we have companion units that are way up on the top of the building that serve the high house. So it was a strategy to minimize the ductwork, to try to balance those systems, and also still maintain that centralized strategy so the ease of the maintenance could be still part of the project.
And these ERVs are what kind of unit?
Yeah, so they're Swagon units. We worked very closely both with our mechanical engineer, Dagger, Engineering, and Swagon to come up with a design that was able to balance the needs for this climate. In the Northeast, we have high humidity conditions, we have cold conditions, so we did an energy recovery ventilation system as opposed to heat recovery ventilation. But there's also times in the year when there might be high humidity in the interior during the colder seasons, and we can potentially work with Swagon to potentially dump that air that might be overly humid and then bring in makeup air. Now you take a little bit of an energy hit when you do that, but it was a way to diminish the risk of potentially having moisture coming back into the apartments and having overly humid air come into the apartment. So it was a great kind of design enhancements that we worked with not only our engineer Dagger, but also Swagon.
And behind us now we're looking at the ductwork, which, I mean, for scale, right, it's massive. These systems serve such a big space, even though it's just the lower house of the tower.
Yep.
Can you talk about the ceiling, insulating, and then managing the penetrations back into the building?
Sure, yeah. Both supply and return come to these units, and that's so that they can pass by each other. They don't actually touch each other, but they pass by each other so that heat and moisture can be exchanged. But that ductwork outside the building envelope, which I really don't like to do, but sometimes you have to do it. So that ductwork that's outside the envelope gets highly insulated. We have it coated with a light color so it doesn't take on a lot of solar heat gain. And then when those things go back into the building, it's really important that you get good quality air sealing. Obviously, you want to keep moisture from coming into the building, so there's a lot of attention that goes into those penetrations. And then that ductwork then transfers back into the floor plate and then goes up through risers to get into the building. Within the building, all that ductwork also utilizes a technique called aerosealing. So basically you pressurize the ductwork, or you allow that this kind of a mist that gets introduced into the ductwork and seals any flaws, any holes, so that you get a really high-performing, efficient ventilation system.
And that addresses both leakage in terms of how much loss you have outside of that ductwork, but it also helps with, from what I understand, measurement at the completion for testing and balancing and getting the right airflows in the right spaces as designed.
Yeah, if you have that leaky ductwork, as units start to come online and start to get populated, it can really throw the whole system out of whack. So having that high performance, good air sealing and not leaky ductwork really helps in the not only in the initial startup, but commissioning and ongoing operation of the system.
This building was really a test case, not just for us, but a lot of agencies were also interested in it. HPD, NYSERDA. They really wanted to know, how do large-scale passive houses really operate? So we put in a pretty intensive monitoring system. So we can actually look at everything. It's not 100% finished yet, but we have outside of the VRF units in the apartments, we can see the set points in the thermostats. We can see humidity levels in the apartments. We can see humidity levels in the outgoing air streams at the ERBs. We can see incoming air temperature, outgoing air temperature of the ERBs, how fast the wheels rotate in the ERBs. We monitor water, electricity, gas. So we have a lot of set points. So it's almost finished. So I'm hoping in 3-4 weeks it'll work. But that took over a year after construction completion to get this set up. And that lesson learned is to really have a very concise spec at construction start that deals with where all the information is going to go, where the head end equipment is, what kind of labeling is needed, what kind of wiring and all that. So you can later on even use different patch panels and have the equipment talk to each other. One big issue with these high efficiency buildings is that you don't just have the heating and cooling things of equipment and then exhaust equipment and boiler. Now all of these pieces of equipment, they need to talk to each other because they influence how they should operate. And so this is a little bit different in a high efficiency passive house.
Talk about the comparison of the costs and the savings. I understand that this is just maybe the first year of real occupied data that you have and costs, but what are you seeing so far?
So that's the big question, right? What is my expense to build a more efficient building, and what are the savings? Do the savings really pan out? And we did quite some research. So it's the envelope, it's the equipment, and it's a lot of QA, QC. You have a lot of people going around making sure that there's really no air gap. Everything is, the air barrier is perfect and it's caulked well, and it takes money. So in this case, came down to approximately $4 million. That is hard cost is $116 million. So that's a little under 4% of construction on hard cost. And then you weigh that against the expected savings, energy cost savings. And we expected that we would make up the cost in approximately 12 years. The building took almost a year to fully lease up. So when we are only now at a point where this building is 100% leased. So we don't have the full operational data, but what we do have is operational data from the lease-up period, and that's also a big lesson learned. We are recovering a lot of energy through the ERVs, specifically, in the winter and the summer. In the winter, it's more important to the owner because we pay for heating. But if the building is mostly empty, there's no energy to recover. And that's actually a big expense in the first year. We don't have the internal heat loads from our tenants, from their equipment, from their cooking. And this is something that we need to learn how to underwrite better. We were very conservative with our underwriting in this building. I would stay that way for the time being until we have more data. But the good news about this building is that we are collecting so much data, and we're not only using that ourselves, but we're making that available to the Passive House Institute, to you guys, whoever wants to look at it, to the agencies, to understand better how to underwrite these buildings and how they operate long-term.
And can I just reiterate again that you said that the easiest part of this building was achieving Passive House?
It was essentially just a little bit better than code. We did a little bit more insulation on the roof. The wall was a little bit more insulated. We had some fundamental things that were here at the site that we had to do to deal with noise and the penetrations to the facade. So it was not that difficult to achieve the Passive House performance here. I think the way our regulatory framework is moving with Local Law 97, Local Law 154, things that are really encouraging electrified buildings, Passive House is a great companion to that strategy. With the systems that we've looked at, the VRF, the ERV, they're really electric-based systems. I think one of the next big challenges that we're all going to be kind of grappling with is domestic hot water, but there's cold climate heat pumps that are out there that are available. If you can do geothermal, that's also an option. You got to worry about balancing the domestic hot water load and the heating and cooling of the earth. But there's technical solutions out there that I think we can bring to bear to really move towards this future of buildings that are electrified. We have to clean the grid to make that all really work and really reduce our carbon footprints. But I think that's the way I hope that the building industry goes.
With the state of the world that we're in, and with every season we learn about the climate crisis in a new and awfully scarier way. What are you taking forward with you into the next project based on what we've learned?
Yeah, so if it's not the pandemic, it's wildfires or intense rainstorms. I think what we are seeing now is really the effects of climate change, and I think the benefits of a Passive House strategy, the improved interior environment, the indoor air quality that you really see from these systems when they come together and are designed right, is going to have huge benefits, huge consumer appeal to move into a healthy building that if there is, there's going to be another wildfire, there's going to be another smoky condition in our city. So to deal with that indoor air quality when it's, really bad outside, I think that's going to be a really important thing, not only for market rate buildings, but for affordable buildings, just for equity and for kind of a democratic ideal of how we should all be living now. So I think that's a really, really important part of the Passive House strategy, is to really make that interior environment, that living environment, safe, healthy, resilient. So I'm a big fan. I'm sold.